taxon and species hypothesis, the theoretical background, and I'm going to show UNITE digital services or analysis programs that we have available. And I guess you all are familiar or at least have heard about UNITE database, and it offers ribosomal DNA IT sequence datasets from UNITE and international nucleotide sequence databases. And it all offers on its homepage UNITE species hypothesis reference datasets for different analytical pipelines, and also third-party sequence annotation options through the PlutoF platform. This means that although in GeneBank sequence might be incorrectly identified, but in UNITE you can add correct identification or any kind of metadata to this sequence, and later these data identifications will end up in the reference datasets that people can download and use for their in-house analysis. There are modest sequence identification options available on UNITE homepage. It's BLAST analysis for up to 10 sequences, but more analysis options are available on the PlutoF platform. And I have grouped or categorized these analysis into 4 different groups. The first is BLAST analysis. So the BLAST-10 algorithm is currently only available on the UNITE homepage, but we are going to add it to PlutoF as well. And this is currently only for 1 sequence at a time. Then there is MassBlaster, MegaBlast utility for batch blast analysis of multiple query sequences. And here I will show in UNITE you can only blast up to 10 sequences, but in PlutoF you can blast up to 1,000 at one time. So you can find the analysis laboratory in PlutoF under the laboratories menu item, analysis lab, and then sequence analysis. You can start new, and here you can select which type of analysis you want to run. And the MassBlaster is the second one. It's part of the BLAST Plus package, MegaBlast. And here you can either upload your sequence file in FASTA format or paste the sequences into this text area. You can choose between 2 output styles. First is regular, and here you can also see the alignments to the up to 2 best matches. And the condensed format is a tabular blast output. And you can also select between 2 different parameters, algorithm parameters, either for similar sequences, which is faster, or for distant sequences. And you can find these parameters here under the info link, the differences of the parameters. It's in the word size used and also the gap extension and opening penalties. And you can also choose against which reference data sets you want to blast your data. It can be only UNITE, only INSD, or also include sequences from environmental samples. And the output includes, select one from here. This one. it includes the best match and also the species hypothesis codes. This is the condensed view of the output, and it includes maximum 30 best matches to query sequence. And you can also look at the condensed view. There is a one-line summary table with one best match, and also the very condensed view of the results, where taxon names and their counts in your BLAST results have been shown. So then next we have this SH matching BLAST analysis. It is basically the same analysis as the previous one, BLASTer, but it has this SH matching functionality. So it uses the species hypothesis code from best match that is available, and includes it in PlutoF output in such a way that you can add species hypothesis based identifications to your sequences. I will show you. So basically the output of this analysis, SH match, what's the SH? Show this another one. What's the SH? This one. So basically you will have a table of the results with the best matched sequence and unit species hypothesis, and also the BLAST score and percentage distance of the species hypothesis. And in PlutoF, you can add SH-based identifications in addition to Linnean taxon name-based identifications. You can see it here. It has identification Laxnum palma, connected to the classification of the tree. And here you also have SH identification, which directs to unite the species hypothesis, and also gives you all the parameters that have been used in this identification. And this one directs to SH view. It's this one. 5 sequences. And why this SH identification could be useful is that if you don't have good Linnean taxon name for your sequence, these have not been described, for example, yet, some new fungal lineages, you can use these species hypothesis codes approximately on species level to show that you have so many taxon, and you can also communicate your reference sequences or results using these codes. For example, you can publish your dataset that can only have these SH-based identifiers or identifications to GBIF. I will show a few examples. Go back. So you can just click on either all or a few of these sequences and then say that add SH-based identifications to these sequences. And here you should also take a look and decide based on these values, blast score percentage and E value, because in this case you have 99.3% similarity, or this is I'm not sure where the coverage is. Here can be quite sure that this sequence belongs to this species. But for example, here you have percentage similarity percentage less than 90%, and it probably it isn't this species. Although I looked at this sequence, and it seems that the author has not based his decision on these scores or percentages. So he has species hypothesis identification with similarity percentage less than 90%. It's not very useful. And to solve this problem, at least in PlutoF, we are planning to rerun all these analysis. Each time we have a new version, run all these sequences through the identification pipeline or BLAST, and add updated SH identification to improve this identification here. And I will also show a few data sets that have been published. These are, I think, high throughput sequencing datasets for which in many cases there is no taxon name available, but for which we have SH identifications. This is a dataset by Kai. I think Kai Ilves, yes. And you can see that if you click on the published dataset in GB, it's more than 5,000 sequences or occurrences that although she has most of her sequences identified as fungi SP, the SH code linked to the sequence can be used to refer to a better name, to more specific name. For example, many are identified to species level. And the SH system is also one part of the GB classification. So they can easily be used for analysis. They are linked to taxon names, in this case, Chronostochus rosea. So I will go forward with the analysis. The next is ITS Extractor, which allows to extract highly variable ITS 1 and 2 subregions from ITS sequences. And then there is also the Protox Fungi, which is a standalone tool for probabilistic taxonomic placement of fungal ITS sequences. So it was developed by Panu Somervo And we collaborated with him to make this tool available and in PlutoF, and to rely on Unites and Index Fungorum's data. So the difference between other classifiers in Protox Fungi is that it accounts for the presence of unknown as well as known but unsequenced fungal lineages when doing probabilistic taxonomic profiling of fungal sequences. And the output is it includes Krona file HTML that can be interactively visualized with web browser, and shows all the taxonomic units for which there are classifications. And it also includes the main 6 probability files, which contain the taxonomic classifications for different levels from phylum to phyla to species. And I will briefly show the output. Should have it somewhere. This one. So there is this Krona chart. It's taxon names and probabilities. And there is also the main prob files. The second level is the phylum level, I think. So for all sequences, it shows it gives you the probabilities to which taxon it belongs on different levels. In the first case, it's the Ascomycota with 0.998 probability. But for example, in this case, it's either fungi or unknown, undescribed lineage, or Ascomycota. These are the main outputs. So let's move forward. Okay, we have one more tool to show, and this tool was developed as part of the EOSC Nordic project that we have been part of for the last year. And the aim of this project is to facilitate the coordination of European Open Science Cloud relevant initiatives within the Nordic and Baltics. And we are involved in the work package 5, which aims at enhancing the cross-border computing solutions by the example of different community-specific portals. And for the biodiversity, the Unite PlutoF is the example or use case portal. So as part of this project, our main goals was to first to package our tools in such a way that it could be easy to deploy and run them in different HPC environments. And the second goal was to integrate or connect the different HPC clusters so that the user could choose which HPC resources he or she has access to, and then use this for running his analysis. So this graph shows the workflow, the state that we started with. HPC environment settings were hard-coded in PlutoF code, and the tools were not packaged, and the setup was done manually, and also the updates. It was quite a lot of work. It's kind of time-consuming to update this. And also we only had connection to University of Tartu rocket cluster. And now, once we have finished with this task, we now can link to different HPC clusters and virtual machines. And we have also worked out procedures how these new clusters or machines, virtual machines, can be integrated, and how the process of adding new resources to PlutoF works. All the tools were packaged into Singularity containers. And we have set up scripts for automated setup. And now the HPC resource can be set at the user level. And we use also different authentication protocols to access this. So why is this useful? Why was this work useful for us? First, now we can add different HPC resources, and we can increase the number of analysis runs for users that have their own resources. And also we can increase the limit of the sequences he or she can analyze. So in that case, he has the resource, and he pays for these resources in his project, and not us. And the second one is that we or anyone else can easily add new tools to PlutoF using this packaging method. And also part of this work included developing this SH matching analysis.
Kessy, can I just comment? Maybe it is good. Yes, this slide. Maybe it's good idea to add country or level information to HPC clusters. Otherwise, everybody understands UT rocket, but Nick and Snink. So it could be nice to see other Nordic countries, maybe. Yeah. Sorry, but maybe it's more informative than to see that already clusters from different countries are connected.
In this project, so far we have a link to a Swedish SNCC cluster and the Swedish SNCC Science Cloud virtual machine. And also 2 Estonian clusters, UT Rocket and NIC-BB. But it doesn't really matter much where this cluster, in which country it is, because the integrating or linking part should be the same. Okay, the SH matching tool. It is also a standalone tool that is available for download in GitHub if anyone is interested in running it locally. And it's for matching query sequences to unite species hypothesis and also discovering new fungal species from eDNA specimens and other samples. And the difference with SH matching blast analysis is the second part, so that it doesn't just give you the best match, but it shows you that these sequences probably belong to totally new species, and it will also give you identifier that you can use in your scientific communication for this. So the SH matching tool applies the same methodology for matching query sequences to unite species hypotheses as we use for calculating these species hypotheses in the first place. And the user will get a list of SH DOIs that the query sequences fall into. And in the case of undescribed species, the species for which SH is missing from the current version, new SH DOIs will be issued by the PlutoF system. And I will also show the output of these. I will briefly describe the output and then show. So the output files include also the Corona chart, which shows all the taxonomic units for which there is taxonomic information from matching species hypothesis and compound clusters. It also includes the error log for info and error messages in different analysis steps, and also the excluded log with the list of sequences that for some or other reason were excluded from the analysis. And then there is the matches folder that includes the main output files describing how many and which sequences from users' dataset fall into existing species hypothesis or form potentially new species hypothesis and or compound clusters. It is a data matrix, and there are different ones for those that are in existing compound clusters and which form a totally new compound clusters. And then there's also the HTML output summarizing the data of SH matches present in these CSV files. And just today I took this same data set that I showed here to see where this 89.79 similarity percent sequence falls into in SH matching analysis. And let's see, it's this one. If I downloaded it, so I can show you the analysis output from this data set. So there aren't many sequences. It was 44 in total, I think. And I think the two sequences were excluded that were identified as chimeric based on research chimera detection. Check this later. Then there is this matches directory. There are no new compound clusters. You can see this is empty, but all the sequences fall into existing compound clusters. So here is the sequence identifier in the system sequence identifier, the status, where it says if it is new, totally new, 3% threshold species hypothesis, or if it is present in an existing species hypothesis. It can also be a new singleton species hypothesis. And for this specific sequence, I think I have it. It was one of those that form a new singleton species hypothesis. It might have been Locknum. I think this one, this Locknum Palmae. So not sure if it is a new undescribed species or if there is something wrong with the sequence. And the output also includes the taxonomy, either from species hypothesis or compound cluster. And at the moment, we don't have the functionality yet developed for providing these new DOI-based identifiers for new species, but it's in the development is in progress at the moment. But these new DOIs should replace these codes that we have only numbers here. So in total, in this dataset, there are 4 new species hypotheses that include more than one sequence and 5 singleton species hypotheses. I will also show the HTML output. It's quite short. So it says that 11 existing species hypotheses on 1.5 threshold were in the output where these sequences fell into, and the number of new and new singleton species hypotheses. And these are all existing compound clusters. And it also shows the taxonomy lineage and the number of sequences, the number of species hypotheses, and links to the species hypothesis. So you can browse this data. And I think I'm almost finished here. I will also invite you to a NEFOM workshop that we are organizing, and the PhD course, if someone feels that it could be useful. So the program is available on Unite homepage. If you click on this recent posts, and you can see the program here. It's about forest biodiversity open data and associated digital services. These scientific presentations on the second day of the conference. It's April 20. You can also see the presenters here. And there will also be a session about taxonomy flash talks. And the course will follow the workshop 2 days. And the program, it's about metabark coding, data management and analysis, mostly in PlutoF. The program is available also here. You are welcome to join. And any questions?
Thank you, Kessy. Plenty of questions. Probably not so much about the course, but in general. So I was sleeping first half of your talk, so I hope you did it in chronological order, because I haven't been very much updated with the most recent activities. So the question is, do you know to what extent these computing clusters are used for such kinds of tasks?
Do you mean computing clusters as such, or regarding our?
Yes, those programs that you have established, how often are they used over these computing clusters? Do you have any information about this?
We have generated some statistics, but I cannot say from my head at the moment. I think it's approximately a few hundred per month, maybe.
Okay, so within 1 year, or what's the period?
No. Few hundred in 1 month, I think.
Okay. And let's say a person like me with maybe 100 million fungolitis sequences is coming, and do I have a chance to analyze this data in this framework, or is it just too much?
Well, this analysis, we have first limits, so you can analyze 1,000 at a time. But I think these are meant for the not for the so-called raw data, but representatives, for analyzing representatives only.
Okay, then
yeah.
If there are 1 million representatives, I should divide this into 1,000 batches.
Yeah, or you can download the standalone version and run it either computer cluster or locally. These are available.
Okay. And why don't you let people to run, let's say, data sets of at least 50,000 representative sequences? Is it computationally too expensive, or because most of the high throughput sequencing data sets are in the order of around 10 to 50,000 OTUs?
Well, there are several reasons, actually. One is the historical reason that we haven't had time to test these tools properly, so that we can say how many sequences each tool can process in a reasonable time and resources. For example, some analysis take more resources and time, but for those that are quick, we should do it, and it's in our to-do list. For example, this Protox Fungi is very fast, and it could easily process, I think, hundreds of thousands sequences very quickly. but the others are slower. And the other question is who should have access to run so many analyses and in such large batches, because this is, I guess, about up to Urmas to say if we want some users who constantly run analysis, and he will pay for it in his project.
If I can comment
yes.
very briefly, I think this is something we will do in future projects, including the EOSC Nordic project, that national HPC centers will be used for such large analysis, because computing is expensive, of course. And this is, but I think maybe Leho can work through this with his or some friends and his work group, and to suggest how to proceed, because computing is expensive, at least in Estonian HPC center. And but I think it's right to ask this question, because this service must handle millions for single analysis, for millions of sequences, because otherwise it is not service. I agree. I think we will work with this issue, and you know, Leho, this service for matching SHs and what Kessy demonstrated in the end, this is opened, I think, Kessy, for 1-2 months only now.
A bit more, I think.
Yeah, but anyway, it is very short time. It is open to everybody. Okay.
Yes,
sorry.
But this is probably a very, very simple matching anyway. So it should be, I suppose, very, very fast.
No, it's not actually, because it uses the same methodology, and this includes the blast part of all the sequences in some cluster. So yeah, it's quite resource demanding at the moment.
Yes, but it can be probably simplified just by using first plus that certain matching threshold, and for those that are not matching, let's say more than 99%, for those you can do this plus. But well, these are anyway the details. Also about this Protox, I haven't used this, but I have used this Chrono chart and found it quite useful for many instances. So just a question about this Protox. Here, what do you need as the input file? Just the taxonomy?
Well, our version is running on, the current version is, I think, running on PlutoF taxonomy, and unite full sequence data set, not just the ones that are in species hypothesis. But you would need this reference database and the classification.
Okay. So if I have my own, let's say, classification table from real environmental samples, can this serve as an input, or?
Yes. So there is this his own GitHub account with the information that you need to process these files.
It's just easier to ask, and yes. Probably you can answer to many people's questions, because at least potential it's a useful tool, especially when the limit is more than 1,000 sequences in this case.
Yes.
Okay, any other questions?
I will just show where you can find these GitHub repositories if you're interested in it. It's under the analysis, and then this info link here. So if you're interested in running it your own and not using PlutoF Workbench for the faster upload, this can be found on Unite homepage analysis page.
Okay, so any other questions? Otherwise, it's only me asking. Are you going to have something ready quite soon that you already can openly discuss at the moment?
What do you mean by opening and discussing it?
Well, I'm sure you are developing many things, but within a time frame of a few months, are you going to have some additional tools?
You mean tools? No, we haven't planned any. I think I'm still working on this SH matching yet.
Okay.
There have been actually talks with one of the partners in this EOSC Nordic project who suggested that why don't we include our tools in the Galaxy framework and integrate Galaxy into PlutoF instead. So this is maybe something to talk about. So you could use all the workflows and the tools that are available in the Galaxy. I'm not sure if you have heard about it or used it.
A bit, but I guess then it's more useful to run those analyses directly through Galaxy because of higher limits of memory. If you can run only very small data sets over PlutoF, it's not very useful.
No, I think these limits in PlutoF should be increased anyway. So this is what we have to do.
Yes, we will certainly discuss and make changes before PhD course advertised by Kessy. So it will happen probably next few weeks.
Yes, and also we have to consider those Pipecraft add-ins so that all those different platforms, they can in a way complement each other more effectively.
Yeah.
Okay, any other comments?
Yeah.
Does anybody have anything in a urgent wish list?
So may I say something?
Of course.
Thank you. So if computing is expensive, so perhaps there could be a possibility to use Google or Amazon cloud. So the user just has to pay for his own analysis. I'm not sure how hard is implementing these APC clusters. Well, but I think like analyzing your few of your own meta-barcoding data sets is not so expensive using those external services.
I think most people that are analyzing their data sets in PlutoF, at least, they belong to some academic institution and they actually have access to these resources. It's just a matter of linking them to PlutoF or integrating. And this is what we actually did in this EOSC Nordic project. So if you have your own resource in the HPC cluster, you can link to it using your own name. So,
yeah, okay.
so you don't have to use Amazon, but you can use whatever you have access to.
Okay, it's strange. Either, well, there would be probably so many questions, but it seems that either people are tired or they are in a way ashamed to ask those questions. But anyway, you can directly email Kessy, Urmas, Sten, myself if you have some specific ideas or specific questions about certain types of analysis, and probably we can find a way how to help out with this.
I just maybe comment or would like to stress one thing what Kessy was telling you, and which is, I think, is most important, at least for me. It is that soon you can actually store your new findings. I'm not saying undescribed species. I think we need to use here undescribed species hypothesis. And if this service will open, I think this is extremely important and new thing actually, because in many your environmental studies, you find, as Leo said, many new species hypotheses at least, and many of them are of course undescribed. That's true according to the code. But in this case, we are talking registration of new undescribed species hypothesis. Then you will get DOI if everything is fine, and you can, and we will work with GBIF and some other players so that you can go directly and publish your data with new DOIs. This will need some more developments from GBIF and other players, but I think this is coming now. And then this is maybe you didn't, I think taxonomists, they understood very well what Kessy was presenting. And this is, I think, huge change actually, that you can registrate your new species hypothesis. Thank you.
Yes, this is a very good and important topic. The main concern is that people should then agree to release their data, sequence data, so that these can receive those SH codes or DOIs in real time.
Yes, of course. Yes.
And
yeah,
we also need to speed up the calculation process, because if every day there are 3 or 4 or 5 researchers who want to append their data, they all want to run those analyses, and it has to be improved. We have to think of a new clustering method, probably, that is not so slow as ++D.
I think registration itself will be slow. and will need at least certain amount of days before you will get the DOI, because there are many issues. And yeah, okay, I will not waste your time, but there must be very clear rules how it will be done, because otherwise it will be mess, and we don't want this. So this part, I mean, I'm not talking about calculations, but giving new DOI to new species hypothesis. This will take a few days or even maybe a week or two to get those.
Kessy.
Yes.
Just to refresh my memory, I checked now my files from January. So it was that this SH matching can handle only full length ITS. Yeah. Because all my Illumina data, I ran these results are empty.
Yes.
Yeah.
Yes.
So are you planning to provide the solution for either ITS1 or ITS2 running separately or no?
Not at the moment, no.
Okay, so these data still.
For this, you should use this SH matching blast instead.
Yeah, but there, this result is not really unequivocal. There you get these best sequence with its usually fault name, and you get several equally similar sequences, and it's sort of much more work there. Okay.
Kadri, you should proceed with back biosequencing of full ITS region.
Yeah, we are. When is the batch coming? We have it in the work. Is it ready now?
2 weeks.
So there's a long queue.
There is a normal queue, usually 6 to 8 weeks.
Okay.
But they have very long Easterns in Norway.
Yeah, but I think for some projects still Illumina is so much cheaper. It will stay for some purposes. But okay, then other pipelines can be used, of course, yeah.
Well, Kadri, you can actually use the pipeline. If you use the standalone version, you just have to change some parameters there so that it would accept. Yes, if you are interested, I can look at it.
Oh, then it's good, really, because I think this output is so much better, and also the advancements that you showed recently. When we analyzed with Robin's data earlier, we mostly got all sorts of errors from many sequences, but I guess you have improved it now. Okay. So when do you expect this new development about assigning SH numbers to these yet let's say undiscovered SHs? When would that be available?
Not before autumn, I think. The summer vacation is coming, and
because I think then this really would deserve a paper of its own announcing about this.
We actually have a paper planned for the SH, so it could include it.
Okay, good.
Or have another one.
Okay, so thanks to everybody for gathering. Time to finish and do some work.